Okay, so today we're going to shift gears a little bit. On Monday, last class, what we were talking about was basically single dosages. Whether that's a dosage that's administered just once or a dosage that's administered every interval of time, but still it's just given as one dose at that time and then repeated as needed. Interval, not intersol. Every so often it's repeated so that it is administered to the patient on a time basis. But still it's single dosage administered each of those occasions. So what we're going to look at today, we're going to switch gears to dosages administered over time. So what this generally is looking at is some sort of a flow rate. So the medicine is slowly, constantly flowing into the patient over this period of time. So there isn't that one single shot dose like we get with our single dosage calculations. It is slowly administered to the patient over time to help maintain a consistent level in the system. Now, because at the beginning it might take a while for medications to build up, there are procedures for that. So what we're going to look at today is IV, intravenous, which is, of course, abbreviated IV. And we're going to look at flow rates. So the flow rate itself is the administration of the medication over time. Now, like I said, some medications need to build up to a level in the body before they're effective. So something that happens here that's outside of the flow rate is something called a bolus. A bolus is an initial shot, basically. It's an initial large single dose that's injected into, usually through the IV, to kickstart the medication. Or sometimes it's given at regular intervals where there's blood testing to see levels in the blood to get it up to a desired level. But a bolus is a single dose added to the IV. We are not going to calculate those here. We're looking at simply the flow rate. That over time calculation is our task for today. So flow rates, as I said, have that element of time in them. An example might be that we have an order for 6,000 milligrams of medication to be administered over a 6-hour period. So there are a couple of ways we can express this flow rate. The simplest way is just expressing it in milligrams per hour. Well, this is nothing more than a unit rate. Remember when we talked about ratio and rates and proportions, most rates are expressed as a unit rate where the second number is just a one single unit. So to do that here, we look at our order and we express it just as it sounds. It is 6,000 milligrams of medication over 6 hours. So for the most part, when we're doing forward calculations, which is what this is, it's a calculation where we're starting with the doctor's orders and trying to move forward to what we're going to administer to the patient. The time is generally on bottom in this rate. Most rates are out of time or out of some sort of other interval designation. We will see some reverse calculations coming up in the next couple of classes where we might vary that. But again, those are reverse calculations. So this is a normal forward calculation going from order to the administration to the patient. Well, like I said, this milligrams per hour has the units here already, milligrams and hours. We just need to convert it to that unit rate. And the way we did that was we divided by the number in the second value. In this case, that's the 6. 6 hours divided by 6 is 1 hour. 6,000 milligrams divided by 6 is 1,000 milligrams. And so this is 1,000 milligrams over 1 hour. So now that that second value, that second measurement is just 1 unit, we can write it with the fraction in the units. So this is 1,000 milligrams per hour. Now, often we want this reduced to a smaller number. Setting it up, many of our infusers can't set up per hour. Many of them have to be set up per minute. So we might want this expressed as milligrams per minute. Now we can start with 1,000 milligrams per minute that we've already calculated, but let's go back and start with the original number, the 6,000 milligrams over 6 hours. I'm going to abbreviate the hours here. So we still want the milligrams. The milligrams as our main unit is still acceptable. So we're going to keep the milligrams. It's just the hours have to be changed into minutes. So we need to get rid of the hours. So since hours are on bottom here, we're going to put hours on top over here. And we're going to minutes, so put minutes on bottom. And our equivalency there, we know that 1 hour is equivalent to 60 minutes. So now the hours will cross cancel out. In our units, we have milligrams and minutes, which is exactly what we want. So now we can go ahead and calculate this. 6,000 milligrams times 1 is 6,000 milligrams over 6 times 60 minutes is 360 minutes. Oops, don't need a comma in there. 360 minutes. And now we have to convert this into that unit rate. So remember, we just divide by the number on bottom in the second value. That's 360. So on bottom, that's going to turn into 1 minute. And on top, 6,000 divided by 360 gives us 16.67 milligrams per minute. Now, a note on rounding. For any of these calculations, the furthest we should ever have to go is 2 decimal places. And you will see that pretty consistently throughout this section of the course, I end up rounding to 2 decimal places. There may be a couple of problems where the numbers get so small that 2 decimal places will lose the information. So we might go beyond 2 decimal places. And there are some cases where we round to a whole number, which we'll point out when we hit them. But again, for the most part, that's a pretty safe bet that we're going to go 2 decimal places with our calculation. So let's look at another example here. Let's going to throw up a doctor's order for 2,400 milligrams to be administered over 4 hours. So there are a lot of ways we could express this. Let's start out. Again, we'll express it as milligrams per hour. Do that calculation. Again, 2,400 milligrams over 4 hours. Pretty simple calculation because it's just a unit rate. So we just divide by the 4 to make that 1 hour on bottom. 2,400 milligrams divided by 4 is 600 milligrams, giving us 600 milligrams per hour. If we were doing it into milligrams per minute, we would start with the 2,400 milligrams per hour again. For 2,400 milligrams over 4 hours, I should say. And we need to get rid of each. Now, typically when I see time, I try to convert the time first. So here we've got to turn the hours, have to turn into minutes. So let's do that conversion. I'll put hours on top, minutes on bottom. And of course, 1 hour is 60 minutes. The hours cancel out. Now we have milligrams on top, and that is what we want. Minutes on bottom, and that's also what we want. So it's a matter of just multiplying this out and then calculating the unit rate. So on top, 2,400 milligrams times 1 hour. 2,400 milligrams times 1, the hours cancel out. This is 2,400 milligrams. On bottom, 4 times 60 minutes is 240 minutes. And now we divide that out to make the unit rate. So we just divide by 240. And so 240 minutes divided by 240 is just 1 minute. 2,400 divided by 240 is 10 milligrams. That comes out to 10 milligrams per minute. So both of these calculations were mass over time. Remember, milligrams is the unit of mass in the metric system. And this is typically how a doctor will prescribe the medication, is the safe dosage is given in an amount of mass of that medication that can be given to a patient. However, most of our infusers that control the IV flow rates, if you have a really fancy one, you can just put in the mass and the type of medication, and you can program in the concentration and all that, and it will do it. But most of the infusers do not do that. Most of our infusers do not do mass over time. They do a volume of medication or a volume of fluid over time. So we need to figure out how to set these up as a volume over time flow rate. To do that, we need more information. We need how the solution is constituted, or the concentration of the solution. So let's look at an order here. Our doctor orders 4,000 milligrams over 8 hours. But then we also look at the label on the bottle, or on the supply, if you want to call it that, and it tells us that that is constituted at 25 milligrams in 8 milliliters. So this is telling us that 25 milligrams of medication is equivalent to 8 milliliters. We mentioned this before, that those are equivalencies and we can use them as conversions. That's saying 25 milligrams equals 8 milliliters. So we'll start out with the doctor's order again. Anytime we are doing a forward calculation, in other words, trying to get from the doctor's order to what's administered to the patient, we will start out with the doctor's order. So here we have 4,000 milligrams over 8 hours. Now, we want this final result in milliliters per minute. But what we're going to do is we're going to actually go through several different calculations here to show you how those results come about. So we're going to start out, before we get to milliliters per minute, we're going to do our milligrams per hour. We're going to do milligrams per minute. And then we'll do milliliters per hour. So you can see how each of those flow rates is slightly different. So the milligrams per hour was just the unit rate calculation we saw. Again, that second number is 8 hours, so we just divide by 8 to make it a unit rate. 8 hours divided by 8 is 1 hour. That's what we want for the unit rate. We want that second number to be 1 unit. 4,000 milligrams divided by 8 is 500 milligrams. So that gives us 500 milligrams per hour if that was how we're setting our flow rate. Again, typically we don't set it that way. So let's start out again with the 4,000 milligrams over 8 hours. If we were setting it to be milligrams per minute, we would have to get rid of the hours. Again, hours are on bottom, so we're going to put hours on top to cancel them out. And 1 hour is 60 minutes. So the hours cancel out. 4,000 milligrams times 1 is 4,000 milligrams. 8 times 60 minutes is 480 minutes. And now we have to divide that out. So we divide out, again, it's the number on that second piece, the 480. So 480 minutes divided by 480 is 1 minute. Again, that's that single unit that we want on bottom. 4,000 divided by 480, I believe that's 8.33 milligrams. Let me double check that before we finalize that. It is 8.33. So that's saying that if we're doing milligrams per minute, that would be 8.33 milligrams per minute. Again, rounding to that 2 decimal places. Well, what about this volume per time? Volume over time. Well, let's start out with our 4,000 milligrams over 8 hours. Still going back and starting with the doctor's order. If we wanted that to be milliliters per hour, so the hours we want to keep, we want to get rid of the milligrams. So milligrams are on top. So to get rid of milligrams, we're going to put them on bottom. And we have this equivalency. 25 milligrams is equivalent to 8 milliliters. Remember we said that's actually a measurement equivalency here. So 25 goes with the milligrams, 8 milliliters on top. So now the milligrams cancel out. We have milliliters per hour, which is the units we're looking for here. So now 4,000 times 8 milliliters, 32,000 milliliters. On bottom, 8 times 25 is 200 hours. And of course, we're going to have to divide this out. We divide by the 200 in the second number there. 200 hours divided by 200 is 1 hour. Dividing 32,000 by 200 gives us, what is that, 16, I believe. 160. I'm going to double check that. It is 160, I'm pretty sure. 160 milliliters. So that would be 160 milliliters per hour if that were our desired flow rate. Now again, if this were an electronic infuser, you could program in 160 milliliters per hour, and most electronic infusers, I should say, that are capable of doing a direct volume like that can convert from milliliters per hour to milliliters per minute. But if we're using either a manual or a mechanical infuser, we need to get it down to milliliters per minute rather than milliliters per hour, because in some cases, for some of the manual infusers, we actually have to time it for a minute and see if it's infusing the correct amount of fluid. We don't want to sit there and have to time it for an hour. So let's start out again with that doctor's order of 4,000 milligrams over 8 hours. And if we are shooting now again for milliliters per minute, both numbers need to change. But as I said, I usually try to change the time first. So I'm going to go from hours to minutes. The hours were on bottom, so I put hours on top. 1 hour, 60 minutes. The hours cancel out. So now we are in milligrams per minute. We want the minutes, we don't want the milligrams. So to get rid of milligrams, since they're on top, we'll put milligrams on bottom. And again, we have that equivalency. 25 milligrams equals 8 milliliters. 25 milligrams on bottom, 8 milliliters on top. The milligrams cancel out, and we now have milliliters per minute, which is exactly what we want. So we'll calculate this out. 4,000 times 1 times 8 milliliters is 32,000 milliliters. On bottom, 8 times 60 times 25, what is that, 12,000 minutes, I believe. I'll double check that. It is 12,000. Then we do our 32,000 divided by 12,0 gives us 2.66 milliliters per minute. Now that sounds like a pretty slow infusion rate, but 2.66 milliliters per minute still contains 8.33 milligrams of that medication. Remember, the medication is concentrated into the fluid. 2.66 milliliters per minute is actually not that uncommon of a flow rate. It doesn't sound like much, but it can be carrying a significant amount of medication to a patient. So since we've talked about different types of infusers, let's talk about a manual infuser now. If you're dealing with a manual infuser, one of the ways, well, the only way a manual infuser can be calculated is in drops per minute. Now, if you recall, our abbreviation for drops, this is back on that page 150 with all the abbreviations, is GTT. Write that a little bit for you. So GTT over minute is drops per minute. Not sure where GTT came from for that abbreviation, but that's what is most commonly used. To get drops per minute, we need something called a drop factor. And what a drop factor does is it's a property of a fluid. And it's based off of the thickness and all that surface cohesion. What it really is describing is it's the number of drops of that fluid in 1 milliliter of liquid. So if I were to take that fluid in a dropper and count out drops, it would take that many drops to get 1 milliliter of fluid. Again, this depends on viscosity. In other words, how thick is that fluid? And it depends on surface cohesion or surface tension, it's sometimes called. In other words, factors that determine how big the drop is. High viscosity, high surface cohesion make for large drops. So that would be a lower drop factor because it takes fewer of those drops to get 1 milliliter of fluid. Thinner liquids, low surface cohesion, have really small drops, so it'd be a high number. So this is typically, for most fluids, it's going to be between 6 to 20 drops per milliliter. Most of our medications actually slightly closer to that, smaller, between 8 and 18 is typically what we have for our medications. So let's take a look at an example of how that drop factor comes into our calculation. So let's look at our doctor's order. Once again, our doctor is going to order, we'll do 3,600 milliliters, or sorry, milligrams, not milliliters, over 8 hours. Our label, now this would be on a bag now instead of on a bottle. The label on our bag is saying that this is constituted at 50 milligrams in 12 milliliters. And it has a drop factor of 18 drops per milliliter. Now remember, we've said this before, every rate is an equivalency. So this here, we've done this 50 milligrams in 12 milliliters, is saying that 50 milligrams is equivalent to 12 milliliters of fluid. So every 50 milligrams of medication is carried in 12 liters of fluid, or the other way around, every 12 liters of fluid carries 50 milligrams of medication. The drop factor looks a little different, but it works the same way. That is saying it takes 18 drops to equal 1 milliliter of fluid. Or again, the other way around, 1 milliliter of fluid is equal to 18 drops. So as we go to start this calculation, as always, we'll start with the doctor's order of 3,600 milligrams over 8 hours. So now what we're looking for our final answer in here is going to be in drops per minute. So we don't want the milligrams or the hours here. We need to get rid of both of them. Like I said, I typically get rid of the time first. So hours being on bottom, we're going to put it on top. 1 hour is 60 minutes. The hours will cancel out. We now have milligrams per minute. I want milligrams, or I want the minutes on bottom. I do not want the milligrams on top. So I need to get rid of those milligrams. So milligrams are on top. I'm going to put milligrams on bottom to cancel them out. And I have to look for an equivalency that has milligrams in it. Up here I have 50 milligrams equals 12 milliliters. So 50 milligrams, 12 milliliters. The milligrams cancel out, and now I have milliliters per minute. Well, again, I want it to be per minute, but I don't want milliliters. I want drops. So I have to keep going and get rid of the milliliters. So milliliters are on top. I'm going to put them on bottom. And then I have to look for something with milliliters in it. Well, this has milliliters, but I've already used that. I can't use it again. That would just convert it back into milligrams, back to where we were before. I have this one here that has milliliters in it. That's 1 milliliter is 18 drops of fluid. And so the milliliters have canceled out. I now have drops on top and minutes on bottom. That's exactly what I want for my final answer. So now we go ahead and calculate this out. 3,600 times 1 hour, or times 1 times 12 times 18 drops. I'm going to have to put that one on the calculator. 3,600 times 1 times 12 times 18 drops is 777,600 drops. On bottom, 8 times 60 minutes times 50 times 1. What does that come out to be? 2,400 minutes, I believe. Check. Something's usually a little off. 8 times 60 times 50. It might be 24,000. It is 24,000. An extra 0. 24,000 minutes. So we have everything. We have this in the correct units. Like I said, drops per minute, drops per minute. All we have to do is convert it down to a unit rate. So I have to divide by the 24,000 in that second number. So 24,000 minutes divided by 24,000 is 1 minute. And I have to do the 777,600 drops divided by 24,000. 777,600 by 24,000 gives us 32.4 drops. So that is 32.4 drops per minute is that flow rate. So a note here on rounding again. So we'd mentioned calculating to 2 decimal places. If this is an electronic infuser, if we're setting up that electronic infuser, most electronic infusers go to 2 decimal places. So we could enter that as 32.40 drops per minute. And the electronic infuser would handle that just fine. However, there's still places where we have a mechanical infuser. A mechanical infuser is just basically a little wheel that spins and the fluid drops into the wheel and is spilled out. or a manual infuser. Now, a manual infuser is simply, it has like a little section of the tube where you can watch the drops drop through the tube, and there's just a little clamp that goes on the tube. You can loosen or tighten the clamp to increase the amount of flow. So you set that tube, set your clamp, and then you have to sit there with your watch and time the drops dropping through that little tube. And so you have to count to the whole number of drops to get that to work. So if you're dealing with a mechanical infuser or a manual infuser, you would go to the whole number of drops. So if this were a mechanical or a manual infuser, 32.4 drops per minute would have to have been rounded to 32 drops per minute. Since it was 0.4, you'd round it down to 32. For our calculations here, we are going to assume that we're using an electronic infuser. So we're going to go to two decimal places in our calculations for drops per minute, unless it is otherwise stated that it's mechanical or manual. We will always make that assumption that it's electronic. So let's look at some more examples. Let's look at an order for 3,000 milligrams to be administered over 12 hours. Our label on our bag is stating that this is constituted as 25 milligrams in 12 milliliters with a drop factor of 8 drops per milliliter. So a little bit thicker fluid here. And once again, we want this result in drops per minute. So we'll start out with the doctor's order. 3,000 milligrams over 12 hours. Now, once again, we don't want either of those units. We want to get rid of the hours, and we want to get rid of the milligrams. I usually adjust the time first, so we get rid of the hours first. 1 hour is 60 minutes. Hours have canceled out. We have minutes. That's what we want, is minutes, is our desired unit. Next, we got to get rid of the milligrams. Milligrams are on top, so we're going to put them on bottom. And we need to look for something with milligrams in it, right here. 25 milligrams in 12 milliliters. So the milligrams have canceled out. We don't want milligrams as our final answer, though. We want drops, milligrams. We don't want milliliters as our final answer. We want drops, so we have to get rid of those milliliters. They're on top, and put milliliters on bottom. And we now have to look for an equivalency with milliliters. Now again, this one has milliliters, but we already used it, so we don't want to use it again. This is saying 8 drops per milliliter, saying 1 milliliter is equivalent to 8 drops. The milliliters cancel out. We now have drops per minute, which is what we want, drops per minute. So on top there, we have 3,000 times 1 hour times 12 times 8 drops is 288,000 drops over 12 times 60 times 25. That's going to be in minutes. That's 18,000 minutes. And we have to divide this out. We'll divide out the 18,000 to make this a unit rate. So again, on bottom, the 18,000 minutes divided by 18,000 is just 1 minute. On top, 288,000 divided by 18,000 is 16 drops. This is going to be 16 drops per minute. Now, 16 drops does not seem like much, but if you think about it, that's about a drop every little under 4 seconds. So it's a pretty easy time to set that up. Another one. So we have an order here of 6,000 milligrams over 10 hours. Our label on our bag is saying we have 30 milligrams in 7 milliliters. Drop factor of 14 drops per milliliter. So once again, we'll start with the doctor's order. 6,000 milligrams over 10 hours. Next, we'll look at getting rid of the hours. Hours are on bottom, so put hours on top. 1 hour is 60 minutes. Hours are gone again. Let's get rid of milligrams. Milligrams on bottom. 30 milligrams in 7 milliliters. Milligrams are gone. Now we still need to get rid of the milliliters. 14 drops is 1 milliliter, so 1 milliliter is 14 drops. Milliliters are gone. We are now in drops per minute. I didn't specify that, but that is what we want our answer in, drops per minute. So we'll go ahead and multiply this out. On top, 6,000 times 1 times 7 times 14 drops is 588,000 drops. On bottom, we have 10 times 60 times 30 gives 18,000 minutes again. And so we just divide out by the 18,000. 588,000 divided by 18,000 is give us 32.67. Again, we round to 2 decimal places, so 32.67 drops per minute. So now there is a set formula that we could use for IV dosage. Actually, there's 4 set formulas we could use for IV dosage calculations rather than going through the dimensional analysis like I did. Well, I said there's 4 different formulas because the formula depends on what flow rate we want our answer given in. Do we want it in milligrams per hour, milligrams per minute, milliliters per hour, milliliters per minute, or drops per minute? The drops per minute require an extra conversion after we've completed the formula. Or we could run into situations where we have to do conversions before we could apply the formula, like this one. Let's say we have an order for 400,000 units of heparin over 4 hours. Heparin is just a blood regulator, blood thinner type medication. So our label is telling us that we are 1 million units in 2 grams. We are constituted at 50 milligrams in 12 milliliters. I have a drop factor of 15 drops per milliliter. So we start with the doctor's order, 400,000 units over 4 hours. Now I still want to get rid of the hours, so I'm going to do that first. 1 hour is 60 minutes, so we'll cancel out the hours. But now I want to get rid of the units. So I'll put units on bottom. My equivalency there is 1 million units is equal to 2 grams. So units are gone. We're now in grams per minute. We want the minutes. We want our final answer here in drops per minute. We do not want grams. However, we look up here and there's nothing else with grams in it. We do, however, have milligrams. So let's convert our grams to milligrams. So 1 gram is 1,000 milligrams, and the grams are canceled out. And so then from there, you need to get rid of milligrams. This is saying 50 milligrams in 12 milliliters. So the milligrams are gone. We're getting closer. We want drops per minute, so we need to get rid of those milliliters. Put them on bottom. We have 15 drops in 1 milliliter, so 1 milliliter is 15 drops. So the milliliters have canceled out. So now we are in drops per minute, which is what we want. So on top, we'll start out with 400,000 times 1 times 2 times 1,000 times 12 times 15 gives us, now this is scientific notation, that 1.44E11, that is saying 144 billion. This is dropped still. That E11 just means the decimal point has to go 11 spots to the right. Over 4 times 60 times 1 million times 50. This is also going to be in scientific notation. So the 1.2E10 is saying we move the decimal point 10 spots to the right. So that is 12 billion. That is minutes. And we divide that out. 144 billion divided by 12 billion is 12 drops per minute. Now, typically what I would do in a problem like this is I would cancel out some zeros. I would at the very least say, well, there's 3 zeros here. I'm going to cancel out 3 zeros here. There's another 3 zeros here. I'll cancel out those 3. So now it's more manageable. It'd be 400 times 1 times 2 times 1 times 12 times 15. That's going to only give us 144,000 rather than 144 billion. Same on bottom. Multiplying that out now would give us 12,000 rather than 12 billion. Keeping it in numbers that our calculator can handle. So as I said, those are the forward calculations. Next class on Friday, we're going to start looking at reverse calculations. And the most important calculation for a reverse calculation is the time to infuse, or infusion time if you want to call it that. And what this is saying is if I have this bag with this volume of fluid in it, how long is it going to take at the doctor's recommended administration flow rate for that bag to be empty? And this is an important calculation because if you have a patient who is requiring a large amount of medication, there's a good chance that one IV bag is not going to do it. You might have to do several IV bags over a period of time. So you have to calculate how long is it going to take for that IV bag to be empty so that you make a note in their chart as to when someone has to go in there and change it. So that's what we're going to pick up with on, on Friday, is with that calculation. For now, homework will be on page 178 through 179, 1 through 21, the odds. With that, you guys have a great day, and hopefully we'll see you all on Friday.